Okay, so induction here with sigma notation. As we do this, we have to make sure we always follow our 4-step process. We'll refer to this here as P sub n. Okay, so step 1, show P sub 1 is true. So that means my n value is 1. So I'm going from r equals 1 to 1. So I'm just going to have the first term, which is 1, 1 plus 1, which is equal to 1 over 2. The other side of the equation, the right-hand side, is 1 over 1 plus 1, which is a half. So it is true for P1. Second step is my assumption. Okay, I am going to assume PK is true. Okay, I must say that. I must tell my reader that I'm assuming it to be true. In sigma notation, what that means is I am going from r equal to 1 to k. And it's still 1 over r plus 1. And that is going to equal to k over k plus 1. This is my assumption step. I will use this to substitute. All right. And so now I must, third step says I must show true for pk plus 1, which means that this sum, r equals 1 to k plus 1 of 1 r plus 1 equals k plus 1 over k plus 1 plus 1, which I know is k plus 1 over k plus 2. That's my task. I do not know if this is true. Do not say it is true. That is my whole purpose. Okay, that's my goal. I want to find out if it's true or not.
Don't you know the second equal sign is true?
Oh. It is true. I should make sure that I'm accurate. And I will go here and the second equal sign is true. I'm going to put it in red so that I know that it's true. Okay, so in doing this we have to use our assumption. Well, to go through the gory details, this summation here, oh, I want to go back to a different color. This summation here, if I go k plus 1 of this, that means I could also do the summation of r equal to 1 to k of this. But that means I must add my k plus 1th term. And my k plus 1th term will be 1, k plus 1, and then this is going to be k plus 1, which is k plus 2. So this here is the summation of all the way to k plus 1. This part here is my assumption. This is what I'm going to substitute right here, my assumption. Substitute. Okay, so by my assumption, I can substitute that in, and I can say that this is going to be k over k plus 1. My k plus 1 term is this. And now I have to get some algebra working here. I'm going to get myself a common denominator by making this k plus 2 over k plus 2. And so it is k squared plus 2k. And I'm going to plus 1. We'll add it together. And my common denominator is k plus 1 and k plus 2. All right. Noticing the top, I know this is my objective. If I notice the top, that factors conveniently to k plus 1 squared over k k plus 1, k plus 2. I can then go and do a little bit of canceling. That square goes away with that. And so I get a single k plus 1 over k plus 2. So I've shown it's true. So, writing my statement at the end, I can say something like, well, since pk is true, we've shown pk plus 1 is also true. Hence, I love saying the power of mathematical induction, the power of mathematical induction, and P1 being true, Pn is true for all, for all positive integers. True for all n belonging to z positive.